In last lecture, we are discussing about advanced macro facility. In that case, where we can use different types of statements and how this that particular statements can be used. The corresponding examples are also discussing that case. Okay, in that particular situation, we have to provide some conditional statements, that is AI of AGO or ANOP, to perform the expansion of the given macro according to the specific condition. Now here we need to consider some other 2 points related to that of the advanced macro facility. That is, according to the advanced macro facility, the two types of expansion of a macro can take place. One is nothing but the conditional expansion, and second one is nothing but the expansion time control, okay, or expansion time loop. Now in this case here, when we consider the expansion, conditional expansion, at that time we need to use the particular, or we need to expand the particular macros according to the given condition. That is, if the condition we are satisfied, then we can perform the expansion of that particular macro. And to handle that particular situation, here we can use the two statement which is discussed in the previous lecture, that is AI statement, which is similar to that of the if statement, and second thing is nothing but the AGO statement, which is the unconditional branching statement. Here we don't require any type of condition in case of AGO statement. Both the statements are used with a corresponding label. If we consider the AIF statement, then we can pass a specific conditional code, or we use some condition code corresponding to that AIF. We pass the operand, we compare the two operands, and accordingly we can perform the transmission of control to the expansion of that statement, which is given the label field. Okay. Now these things are considered or discussed both AIF and AGO statement in the previous lecture. Now in this case here, when we consider the conditional expansion, while writing a general purpose macro, it is important to ensure execution efficiency of its generated code. That is, to improve the efficiency of a code, we require the conditional expansion, that is, we use that particular macros. Now in this case here, this is achieved by ensuring that the model statement is visited only under specific condition during the expansion of a macro. That is, when we execute the, or we perform the expansion of macro one by one statement, that is in the sequential order, it doesn't matter, that is, the efficiency of that particular code is more. Here what happens, if we want to perform the execution of some statement under a particular condition, at that time we need to pass that particular condition. Here macro supports such a conditional statements according to the given AIF and AGO statement. If we improve, or if we write the code according to the specific condition, we expand the particular statement under a specific condition. Here macro allowed to do that particular task, and this task is handled. That is, how to do that particular task. That is the example answer is given to here. That is AIF or AGO statement can be performed that type of a purpose. Okay. Now here we consider one example, that is here we clear our doubts. That is same as above. In this case here we consider the expression A minus B plus C. Now to evaluate this particular expression, that is to write the macro corresponding to this particular expression, we have to perform first A minus B, and then next time we can do B plus C. Now here what happened, we use the particular macro definition. Here only ANOP declares the particular symbol. Now this symbol is nothing but our sequencing symbol also, but here we don't have to specify the dot. That is in the declaration, that here we require the dot only. That is ANOP, we declare the sequencing symbol. For that purpose we use this ANOP. Okay, we declare two sequencing symbol, only and over. Here macro, we start the macro. Eval, name of the macro is nothing but the eval, the positional parameter given to that macro, and X and Y and Z. Now next thing is nothing but AIF, that is where we can pass the condition. What the condition? That is and Y equals to and X. Then our control transfer to the only statement. Okay, if condition is satisfied, that is true, then only. That is, here we can use move A register and Z. Okay, the value of a Z will be moved to the register A register. That means control directly expand this particular statement under the given condition, and Y equals to and X. Both value are equals. Then we can transfer the control for the conditional expansion, or we expand the statement that is given at the only particular only sequential symbol. Okay. Now next thing is nothing but move r a register and x. Now this statement is not expanded if this particular condition is satisfied. जर तुमचे AF स्टेटमेंटची कंडिशन सॅटिस्फाय झाली तर मूव आर ए रजिस्टर हे स्टेटमेंट जे आहे हे एक्सपांड होणार नाही. डायरेक्ट कंट्रोल कुठे ट्रान्सफर होईल तुमचा ह्या लोकेशनला ट्रान्सफर होईल. ओके. नाउ नेक्स्ट थिंग इज नथिंग बट द सब a register and y, add a register and z, AGO dot over. Now in this case what happen, if our condition, that is and y and x equality condition does not satisfy, then we can execute or expand this particular statement, that is move r sub add AGO. These statements were expanded, and the given statement move r a register, this statement does not expand if the condition is not satisfied. That is, according to the condition we perform the expansion of that particular macros, and at the end of this particular expansion, आता इथे बघा हे स्टेटमेंट एंड झालं, एक्सपान्शन झालं याचं, तर इथे काय झालंय, एजीओ स्टेटमेंट अनकंडिशनल ट्रान्सफर, कंट्रोल डायरेक्ट कुठे ट्रान्सफर केला, ओव्हर सिक्वेन्सिंग सिम्बॉलला, म्हणजे काय झालं, मॅक्रो तुमचा एंड झाला. मॅक्रो इथे येईल का, आता ह्या स्टेटमेंटला जर इथनं तो डायरेक्ट एंडला जातोय तर तो ओनलीच्या सिक्वेन्सिंग सिम्बॉल जिथे आहे त्या स्टेटमेंटला तो मॅक्रो कॅरी फॉरवर्ड होत नाही. That is nothing but we expand the particular macro according to the specific condition. If conditions satisfy, then we expand the given statement. Otherwise, we expand other type of a statement. That is the conditional expansion in case of the macro expansion. This is nothing but the this thing can be considered as an explanation of all about that particular example. Okay, under all conditions where will be satisfied. Now, next thing or next type of expansion is nothing but the expansion time loop. Why this expansion time loop is required? Now in this case here it is often necessary to generate many similar statements during the expansion of a macro. That is, we have some statements which has the common in case of the macro, but here we need to perform some changes into that particular statements. We increase the value or we decrease the value of that particular statement. We execute the common statement more than once in the macro. Now it is the tedious task to the programmer. Now you can see this particular example here, macro clear and a move r a register equals to 0, then move m a register and a move m a register and a plus 1 move m and a register and a plus 2. Now we can see this particular statement. These three model statements where we have the common. Okay, this is the common. Only the changes where will be done at this particular value. Now in this case here a register value of a can be considered as a byte value, single byte value, and these three model statement move m move m move m can store the value or store the address of this particular a in the byte format according to this increase type. Suppose here a represent 1 byte, here a 1 plus 1, that is the 2 byte, here 1 plus 2 plus, that is the 3 bytes. According to this condition, according to this particular incrementation, we can execute the same statement move m move m move m model statement. Now this is the repetition of this particular single statement according to the specific operation. Now to avoid this repetition of statements under the macro, for that purpose we can use expansion time loops. Now this expansion can take place. आता इथे तिन्ही स्टेटमेंट ज्यावेळेस मॅक्रो कॉल होईल त्यावेळेस हे तीन वेळेस हे स्टेटमेंट तिथे एक्सपांड होणार. Instead of the expansion of 3 times the common statement, we expand it only once, but under a specific loop. Okay, expansion time loop, it is similar to that of your while loop, for loop, or do while loop, just like that. Here we can consider the expansion time loop. Now here this can be achieved by writing similar model statement in the macro. Those statements which are comes repeatedly same and it is repeatedly more than once, we can write them into a single macro and we can call that particular macro. Here when called clear b, we can call the macro. Here b is the actual parameter, okay, and a is the formal parameter. Move m statement puts the value 0 in a register. Okay, then move r statement put the value 0 in the a register, while the 3 move m statements store this value in 3 consecutive bytes with the address b plus 1 and b plus 2. Here only the parameter value where we changed. Okay, address value will be got increased by 1. Now this is the repetition. To avoid this particular repetition, that is alternatively the same effect can be achieved by writing an expansion time loop which visits the model statement or a set of model statement repeatedly during the macro expansion. Here we can consider these same tasks using the expansion time loops variables or expansion time loops. Now in this case the model statement visited more than once or repeatedly under a specific condition in the during the macro expansion. Here we can perform the expansion time loop can be written using the expansion time variable. Okay, here we need to consider this EVs, which is discussed previously also. Okay, in expansion variable जे आहे ते आपण already discuss केलेले आहे. Now we can use that expansion variable during the expansion time loop, and expansion time control transfer statements, that is nothing but the AIF or AGO. According to the specific condition, we need to implement the particular loop. Okay, you are familiar with that particular situation. Now we consider this particular example, clear and x and n. Here local variable will be declared, or local variable considered as and yum. Then we set the value of yum as a 0, and we can write move r a register 0. 0 value will be move into the register a register. Now we can do this particular. आता जो repeated task होता आधीच्या example. Now same example can be written in this particular way. Here we can see that dot more, it is a sequencing symbol. Okay, move m a register and x plus and m. We can set the value for m as 0, and here a is nothing but our actual parameter. Okay, and m set and m plus 1. We increase the value of m by 1 when we repeat this particular statement. Okay, this is the more statement. Again, here we can check the condition, and m not equals to and n. N, it is how many times we want to increase that value consider in case of the n, and we increase the value of n that number of times. That is nothing but the we can not equal to our value of m does not satisfy that n value. Okay, and if the condition is true, that is not equality condition is true, then we transfer the control again more. That is, this particular statement value of m plus 1 is repeated more than once till the value of n. We pass the value of n when we call the macro. ज्यावेळेस तुम्ही मॅक्रो कॉल करणार त्यावेळेस तुमचा ऍक्च्युअल पॅरामीटर तर पास होईल, पण तो किती वेळेस तुम्हाला त्या ठिकाणी तो रिप्रेझेंट करायचा आहे. नाउ इन दिस केस वी कॅन रिप्रेझेंट दॅट ऍक्च्युअल पॅरामीटर 3 number of times. The value of n should be considered as 3 for this particular purpose. Okay, b plus 1 b plus 2, like that. Here we can consider x plus 1 x plus 2. We can pass the value of n as a 3 till m not equals to 3. Then we can repeat this particular statement. Okay, स्टेटमेंट त्या ठिकाणी काय होत राहील, तुमचं रिपीट होत राहील, आणि त्या पद्धतीने ती एक्स ची व्हॅल्यू त्या पद्धतीने त्या ऍड्रेस काय केलं जाईल, स्टोर केलं. दॅट इज नथिंग बट द एक्सपान्शन टाइम लूप. इन सिंपल वर्ड, expansion time loop, it is nothing but the loop statement. Okay, and that loop statement is executed with the help of expansion time variables. Okay, local or global expansion time variable will be declared here. M is nothing but the expansion time variable which is the local in that particular macro related to that macro. And here we can use some conditional transfers, that is AGO statement or AIF statement. Most of time we can consider the AIF statement, and we transfer till the condition is true. We can repeat this particular statement. Okay, that is, we avoid this particular model statement, common model statement repetition, writing or expanding the same statement more and more times. We use this particular expansion for that particular statement, that is the looping statement. That is the expansion time loop variables or expansion time loop in case of the macro expansion. Now this is all about the macro and macro expansion, how macro can be written or how macro can be expanded. Now till we are discuss all the things corresponding to that of the macros. What is the macro, how we can write the macro, how we can end the macro, how we can call the macro, how they are expanded, what are the advanced macro facility related to that of the macros, which facility macro will be provided. Okay, all these basic things which are required corresponding to that macro we are discussed. Now after all, we can consider how we can design that particular macro. Okay, macro preprocessor kasa design करायचा. That is, here one more thing is remaining, that that is the other facilities for the expansion time loop. Corresponding to the expansion time loop, we can use this particular assembler, that is M68000 and Intel 8088 processor. Here this particular processor can provide the explicit expansion time looping constructs. That is, in this case here we consider the expression should evaluate to the numerical value during the macro expansion. The expression ची जी value असेल ती काय केली जाते, macro expansion च्या वेळेस त्या ठिकाणी evaluate केली जाते, numerical value त्या ठिकाणी find out होते. Now in this case here we use two statement, that is repeat statement, that is repeat corresponding expression. किती टाइम्स तुम्हाला ते मॅक्रो रिपीट किंवा ते अंडर स्टेटमेंट रिपीट करायचं, ती व्हॅल्यू या ठिकाणी न्यूमेरिक व्हॅल्यू फाइंड आउट होते, आणि रिपीट स्टेटमेंटच्या अंडर काय केलं जातं ते स्टेटमेंट दिलं जातं. नाउ स्टेटमेंट बिटवीन रिपीट अँड एंड एम. ओके, statement between repeat and m statement would be प्रोसेस फॉर द एक्सपान्शन दॅट इज द एक्सप्रेशन नंबर ऑफ टाइम्स. तुम्ही इथे आपण जसं आधीच्या केसमध्ये ह्या एक्झाम्पल मध्ये आपण एक स्पेसिफिक कंडिशन वापरली आणि त्या कंडिशन नुसार ह्या ठिकाणी लूप क्रिएट केलं. तसं आता नवीन लूप जे आपण देतोय त्या ठिकाणी रिपीट स्टेटमेंट आणि एमेंड स्टेटमेंट मध्ये ते लूप मेन्शन केलं जाईल. नाउ यू कॅन सी द एक्झाम्पल दॅट इज रिपीट टू डिक्लेअर 10 कॉन्स्टंट विथ द व्हॅल्यू 1 2 3 अप टू 10. वी नीड टू कन्सिडर दिस नंबर ऑफ टाइम्स. वी रिपीट दॅट पर्टिक्युलर व्हॅल्यू ऑफ m as 10 times. We consider the macro constant. Const 10 value will be considered here. Local variable will be declared, that is expansion time variable. Here value set of m set to 1. Repeat. How many times we can repeat? 10 times. कोणते स्टेटमेंट रिपीट करायचे? DC and m. Okay, declare the constant of a value that is expansion variable m. m ची व्हॅल्यू काय होईल? कॉन्स्टंट डिक्लेअर होईल. ती किती असणार आहे? इथे पुढे दिलेली बघा ती and m set and m plus 1. That is first time we can consider a value of m as a set by 1, that is the 1. Then next time we can set value m plus 1, that is 2. Then end m. Up now till the value of this 10 or repeat can reach to the 10 number of times, that is value of m reach to the 10, we can continue or we can execute these two statements 10 times. And at the end of or when value of m reaches to the 10, then end m this statement is executed and the repetition or the loop of this particular statement can be completed and our macro will be end, that is end statement will reach. Okay, this is the another way to perform the expansion time looping in case of the macro expansion. Okay, all these things about related to that of the macros. We discuss all the concepts related to the macro, how we can write the macro program with the help of all these things. We also consider the advanced macro facilities provided by the macros. Now we need to consider designing of a macro preprocessor. Okay, till we discuss about the macros, we write the program with macro. We have to complete this first part, that is the programs with macro definition and calls. Okay, now we need to conclude on this particular part, or we need to perform the explanation about macro preprocessor, how macro preprocessor are work or how macro preprocessors were designed. Okay, according to the assembler, we discuss about the assembler, how assembly program can be written and how that assembly programs are executed. We need to execute the assembly program, we require the assembler. Okay, we perform the designing of that assembler, but before that of we need to identify the component related to that assembly language. Similar to that here, first of all we discuss all the macro related concept. We write the program, assembly program with macro, how they are expanded, how they are right in the particular condition, how the macro calls where we perform, how variable will be passed to that the macro, which type of variable or which type of parameter are given to the macros. All these things are comes under the macro program, that is a program with macro definitions and corresponding call. We discuss only the first part. We need to discuss about the macro preprocessor, how macro preprocessor can process this particular program. Okay, for that purpose we need to design the macro preprocessor, and when we design the macro preprocessor, we have to get the output from that macro preprocessor, that is the program without a macros. Output of the macro preprocessor is what? We can get the program without macros. This program is given to the assembler. Now remaining part from that program, that is from assembler, we are already discussed. Okay, assembler पासून पुढचा जो भाग आहे तो आपण ऑलरेडी डिस्कस केलेला आहे, तो आपण ऑलरेडी त्या ठिकाणी स्टडी केलेला आहे. बट वी नीड टू कन्सिडर द मॅक्रो प्रीप्रोसेसर, that is the macro preprocessor accept the assembly program containing the definition of macro calls and translate it into an assembly program which does not contains any macro definition and any macro call. That is the complete assembly program will be given as output after the pre-processing of the macro program. Okay, now here the program from form output by the macro preprocessor can be handled over an assembler to obtain the target code. How target code will be evaluated, this can be the task of the assembler, but before that of the assembler we consider the macro preprocessor. Now we need to design this macro preprocessor, which data structures or which type of steps will be handled to design the macro preprocessor. That part should be discussed in next lecture. Now today we can conclude here, that is we can start, or in next lecture we directly consider the preprocessor, designing of the macro preprocessor. Okay, Now today we conclude our session at this particular point.